Today we're going to be talking about distance on a coordinate plane. Okay, and our learning target is how can we find the diagonal distance between 2 points on a coordinate grid using the Pythagorean theorem. Okay, so on a distance on the coordinate plane, to find the distance we need between 2 points, we need to use the Pythagorean theorem. Okay, we're going to plot both points and then connect them with a line, and then draw the vertical and horizontal lines so that the right triangle is formed. So we're going to write a right triangle with those two lines. Okay. Use the coordinate grid to count the height and the base of the triangle you drew, and those are going to be the legs, the values of A and B. And then the last part, it says plug in the height and the base of the triangle into the Pythagorean theorem to find the length of the diagonal, which is the distance between the 2 points. Okay, so just as a reminder, Pythagorean theorem, we do have a right triangle and right triangles only, where we have our A and B, which are the legs, and then C is the hypotenuse, and we have A squared plus B squared equals C squared. Okay, and we use the formula to find what the hypotenuse is. Sometimes we also use it to find the missing leg of the triangle, missing value of the leg. Okay, so let's do some examples. Okay, so here it says find the distance between the points R and S, round to the nearest hundredth. So here R and S is going to be this line segment right here, which is the hypotenuse. If we look at right here, this is our right triangle. Let's count how many units Q to R is. So that's 1, 2. So I know this is 2. And from Q to S is 1, 2, 3, 4. So we have our side lengths 2 and 4. Those two side lengths made that 90 degrees, so I know my legs, or my A and B, is 4 and 2. Remember, it doesn't really matter what each one is as long as they're both A and B. Okay, so that means C, we don't know what that is. Okay, so we got our formula is A squared plus B squared equals C squared. A squared, we decided to make it as 4. It could be 2, right? Because it's also a leg. Plus 2 squared equals C squared. When C squared, I don't know what that is, so I'm just going to leave it as C squared. Okay. We can put this into our calculator. Okay. And we should get 20. Oops. And that is equal to C squared. Remember, we have to get rid of this square. And if you remember, the opposite of a square is going to be a square root. So I'm going to take the square root of both sides. And the square root of 20, that's something that we should put into our calculator. And we get 4.4. And it says nearest 100, so I need 2 decimal places. Let's do 4.47. Okay, and that is C. Calculate the distance between the 2 points, round to the nearest tenth. So here we have a point here, and then we have a point here. It's already connected, but we don't know what the legs are. Okay, we're going to write or draw a horizontal line and a vertical line, like this. And you guys see right here, that's where they make that triangle. So that's why I'm going to make my triangle. So I'm going to connect it like this. And then this. Now these two are my legs, and those are going to be A and B, right? It doesn't really matter which one is which, as long as they're both A and B. Okay, so for A, this is 2 units, right? So this is 2. And then here we got 1, 2, 3, 4, 5, 6, 7, 8. We got 8 over here. So we got A, B, C. Let's make A 2. B 8, and then C, I don't know what that is. I don't know what C is. It's a hypotenuse, but I don't know how much it is. That's what we're trying to find. Okay, so our formula, we got A squared, which is 2 squared, plus 8 squared equals C squared. We're going to put 2 squared plus 8 squared in the calculator. I'm going to put this in the calculator, and we get 68. And now we have to take the square root of 68 to get our C. And so they do want nearest 10, so that's 1 decimal place. It's going to be 8.2. That's C. That's going to be the distance. You can put 8.2 units, squares, whatever you like. Little unit squares. Okay. Now let's look at this one. It says find the distance between the 2 points. Now we only have points. We don't have a line. We don't have a triangle. We don't have nothing, right? So from P to Q, we're going to first draw a straight line from P to Q, as straight as you can get. It's okay if it's not perfect. And then we have to draw that triangle. And so we have a triangle that can be formed right here, right? So let's draw that triangle. And let's see how much those side lengths are, because those are going to be the legs. So let's see how much those are. So we got 1, 2, 3, 4, 5, 6, 7, 8. So we got 8 over here, and 1, 2, 3, 4, 5, 6. 6 down here. So we got A, B, C. C, we don't know what that is, right? A and B can be 8 and 6. It doesn't really matter which one it is, as long as they're A and B, A or B. So we do our formula, 8 squared plus 6 squared equals C squared. And let's see, we're going to put this in the calculator. So we got 8 squared plus 6 squared. We get 100. And then to get our final answer, we do have to take the square root, because this right here, this can't be 100, right? That's just impossible. Let's see. Square root of 100 is going to give us 10, I believe. Yep. And that is our units. That's how much C is. C is 10. Okay. For the next one, we're actually going to incorporate transformations with this. We're going to plot L, which is 4, -2, on the coordinate grid first. So 4, 2. -2, sorry. So down here, that is L. And then we're going to translate the point using the algebraic rule. XY is being changed to X plus 3 and Y plus 7. Mark this as L prime. So this right here, I know it's going to be right 3, and then this is going to be up 7. So I'm just going to go to the right 3, 1, 2, 3, and up 7, 1, 2, 4, 5, 6, 7. And that's my L prime. Okay. If you wanted to do the get the 4 into this, we would get 4 plus 3. We get 7, and then -2 plus 7. That will give us a 5, right? Yes. So this is a point L prime, which it is, if we count over 7 and up 5. Okay, so we're going to find the distance between those two. So we're going to find the distance right here. Okay, that's going to be our C, okay, our hypotenuse. So there's 2 ways we can do this. We can draw our triangle like this, right? Have a triangle like this, or we can draw a triangle like this. But luckily, it's the same distance diagonally, so it doesn't really matter which one you use. Okay, I'm going to use the one that's, let me move this over. I'm going to use the one that's like this. Oops. Okay, so we have 3 here for L, and then 1, 2, 3, 4, 5, 6, 7. Okay. Oh, that's a coincidence. Or actually, I don't think that's a coincidence. We got 3 and 7, and those are our transformations that we have over here. That's kind of cool. So let's do A, B, C. A is going to be, let's make it 7. B, let's make that 3. And then C, we don't know what that is. So 7 squared plus 3 squared equals C squared. We'll put 7 squared plus 3 squared into the calculator, and you get 58. And then let's go ahead and take the square root. we get 7, or how much? Nearest 100, so 2 decimal places. Let's do 7.62, because the next number is a 5. It's like this in the calculator. Because this is a 5, this 1 turns into a 2. Okay. So C is going to be 7.62. In our last example, we have a point M, which is 9, -3, is dilated by a scale factor of a half. Yeah. Use the coordinate grid to find the distance between the 2 points. So M is going to be 9. So let's count 1, 2, 3, 4, 5, 6, 7, 8, 9. And down -3. So right here. This is M. And it's a scale factor by a half. So M, we know, is 9, -3. But M prime, we need to multiply by a half on each one. So a half of 9 is going to be 3. And half of -3 is going to be -1.5. Okay. So let's go ahead and put those into the graph. So we got 1, 2, 3, 1.5 right there. Just like the other one, you can do a triangle like this, or a triangle like this. Okay. It doesn't really matter which way. Okay. So down here, we got 1, 2, 3, 4, 5, 6, and then here we got 1.5, because we know it's 1.5, so we know it's a half, right, in that middle section. So A, B, and C, we got 1.5 and 6 as A and B, A or B. And then C, we don't know what that is. So let's do 1.5 squared plus 6 squared is equal to C squared. Put 1.5 squared plus 6 squared in the calculator, and we get 38.25. And then we do have to take the square root of both sides, so we can get C by itself. Let's do square root of 38.25 is going to give us 6.18. It doesn't give us the decimal, so we're just going to put 6.18. 2 decimals.